Hello students, welcome to Educate. In the last video, we have discussed about some characteristic of transition metals. In this video, we will discuss about some important compounds of transition metals. Let's see. One of them is potassium dichromate. You already know that more be the oxidation number, more be the covalent characteristic, because to release that number of electron, high magnitude of energy will require. So that magnitude of energy will not available at the room temperature. Practically that amount of energy will be not available. So the transition metals form covalent compound. So let's see here. One of the example is potassium dichromate, K2Cr2O7. First of all, its method of preparation. So transition metals prepare the potassium dichromate prepared by ferrochrome. This is an ore that is called ferrochrome. Here also written ferrochrome or chromite iron, ferrochrome or chromite ore. Okay, or that is also called ferrochrome. Ferrochrome or chrome iron. So this one is called ferrochrome, that is obtained by ferrochrome or chrome iron or chromite ore. How does that happen? This potassium to this ferrochrome, the sodium carbonate get passed in presence of oxygen. Ferrochrome reacted with sodium carbonate in presence of oxygen. As a result, there will be formation of sodium chromate. This one is sodium chromate, and it is soluble in water. So it will be soluble in water, and Fe2O3 form which is insoluble in water. So ferrochrome firstly reacted with sodium carbonate in presence of oxygen. Ferrochrome reacts with sodium carbonate in presence of oxygen. So there will be formation of sodium carbonate and Fe2O3, the CO2. The CO2 is gas, so it will escape out from the vessel. So in the solution there will left sodium chromate and the Fe2O3, that means ferric oxide. So ferric oxide will filtered out. So in the solution there will be only sodium carbonate. Now acid will pass through this sodium carbonate. So acid will pass through sodium chromate. So when acid will pass through the sodium chromate, there will be formation of sodium dichromate. And it can be crystalled out. It will get filtered out. There sodium that will be Na plus will be soluble in water, so that will remain in the solution, and sodium carbonate that can be separated through crystallization. That will be firstly what happened. The chrome iron or ferrochrome that will react with sodium carbonate in presence of oxygen. The ferrochrome, the reaction, due to this reaction, there will be formation of sodium chromate and Fe2O3, of which Fe2O3 is insoluble in water and sodium chromate is soluble in water. So Fe2O3, that is ferric oxide, will separated out, that will filtered out Fe2O3, and in the solution, then acid will get passed. In this acid, the sodium chromate will left. So when acid will pass through this sodium chromate, there will be formation of sodium dichromate, and this sodium dichromate will be separated by the process of crystallization, and then after that will be treated with KCl. Then after this sodium dichromate will be treated with KCl. So that case here, sodium will combine with chlorine form NaCl, and potassium will combine with this remaining portion of dichromate. So there will be formation of potassium dichromate and NaCl. Now this potassium dichromate can also be separated out by the process of crystallization. That is here. So it is given here one characteristic of chromate and dichromate. So earlier you have seen that when acid was passed through the chromate ion, there was formation of dichromate ion, and when alkali will pass, alkali will be treated with dichromate ion, then there will be formation of chromate ion. When acid will be treated with chromate ion, there will be formation of dichromate ion, and when alkali will pass, alkali will be treated with dichromate ion, there will be formation of chromate ion. That means the chromate ion and dichromate ion both are interconvertible. When acid will be treated with chromate ion, there will be formation of dichromate ion, and when alkali will be treated with dichromate ion, there will be formation of chromate ion. That is. Now about the structure, I have discussed about this one also, that have both that chromate ion have tetrahedral geometry. Chromate ion and dichromate ion has two tetrahedra joined at a point. That means the two tetrahedra joined at the oxygen. So that will be dichromate ion. Chromate ion here has tetrahedral geometry, and dichromate ion has the geometry of two tetrahedra pointed joined at the oxygen atom. Okay. Now oxidation property, listen. When the dichromate ion will be treated with acid, there will be formation of Cr3+. So you already know the dichromate ion or potassium dichromate that act as a strong oxidizing agent. The potassium dichromate is an important oxidizing agent in organic chemistry. For the 12th board examination, in your NCERT book, two oxidizing agent has been given, that is potassium permanganate and potassium dichromate. So potassium dichromate is an important oxidizing agent in acidic medium. So in acidic medium, it will oxidize to Cr3+. Okay. So since dichromate is an oxidizing agent, so it itself will get reduced. So dichromate ion will dissociate into Cr3+. Here the oxidation number of chromate is +6, and oxidation number, so +6 to go +3. So reduction took place. I minus here, since it's the strong oxidizing agent, so it will oxidize iodide ion into iodine. Sulfide, here it is hydrogen sulfide. Sulfide is what ide is added when a non-metal do ionic bond formation with a metal, or that means when a non-metal directly bonded there. So here it is hydrogen sulfide. So here oxidation number sulfur -2, so here 0 oxidizes. So dichromate ion, when acid pass through there, ferrous ion, so that means ferrous ion will convert it to ferric ion. Okay. That is here for the 12th board examination. It's sufficient to know you that directly question will be given in this form, and like here SN2 plus converted to SN2 plus, Fe2 plus into Fe3 plus. But for NEET examination as well as for the IIT main examination, and particularly for IIT main examination, there is very importance for this one, which I am going to teach you for the IIT mains as well as for the NEET examination, and only more important for the IIT main examination. So let's see here how in the examination question will be there, in which form. So let's see. Question will be here Ki that will react with K2. So what will be the product here? So let's see here how to that. It's the oxidizing agent K2Cr2O7. So oxidizing agent, so that will convert it to Cr3+. Now iodide ion, that will oxidize into I2. This one. Actually here it is in Cr3 plus, that may be Cr2O3 also. So on the place of, you can also write Cr2O3. This one plus H2O here. Balancing you'll be able to do when you will study the redox reaction. In the redox reaction, I tell you how to balance the reaction. But how to add this reaction, then let's see. Listen right now. So reaction will be in this form. Ki react with K2Cr2O7, and how to balance them. So dichromate ion is an oxidizing agent, so itself will get reduced. So that will reduce into Cr3 plus or Cr2O3, and iodide ion will oxidize into iodine, and K2Cr2O7 that also gives H2O, that is takes place in acidic medium. How to balance the reaction, that we will discuss in the redox reaction. So same here, this one I have told you Sl2 plus will oxidize into Sn4 plus and Fe2 plus into Fe3 plus. Very easy it is here, because potassium dichromate or sodium dichromate or any other dichromate acts as an oxidizing agent. So it will oxidize iodide to iodine, Sn2 plus to Sn4 plus, Fe2 plus to Fe3 plus, same H2S to sulfur, like that here. Let's see, then after is potassium permanganate. How that prepare here? So firstly, alkali pass through MnO2 to prepare the KMnO4. For MnO2, the Oates MnO2 will be taken KOH, but that means alkali KOOH or NaOH, anyone, this much. That will be taken. That KOH or NaOH will react with MnO2 in presence of oxygen. There will be formation of potassium manganate. This one here, potassium manganate. And then after, once the potassium manganate will form, then after acid pass, so there will be formation of potassium permanganate. It is actually here KMnO4, MnO4 minus, or that means KMnO4, whatever you want to write. Okay, so there will be formation of potassium permanganate and MnO2 will here. But keep in the mind, this MnO2 has not regenerated, because here 2 moles of MnO2 and here 1 mole of MnO2 has been evolved. So you don't say that MnO2 is catalyst. Actually, MnO2 is a reactant here. MnO2 is a reactant only. Overall reaction will be what? Listen here. How to write the MnO2 whole reactions. So here is 3 moles of MnO2 minus taken here. Here 2 moles has been taken. So what to do? Multiply this equation by 3 and this equation by 2. So 3 to the 6 MnO2. Product we should write like later on. Okay, if you write. Add all of them. So here is 6 MnO2, 2 MnO2. So here 4 MnO2. Six KMnO4 here. 6 KMnO4, 4 KMnO4. K2MnO4 here it is. So this K2MnO4, this K2MnO4 cancel out. 6H2O, 4H2O. So overall reaction will be 4 overall reaction. That will be equal to what? 4 MnO2 react with 12 moles of KOH plus 3 oxygen so that is here. Overall reaction is O plus 10H2O. Overall reaction is that much. This one is overall reaction. Okay guys, this one you check also. It might be I did any mistakes in the addition and subtraction. So that was about overall reaction was that. Okay, this one. Now this MnO2 was in the sort that has been written. Firstly to the MnO2, firstly the alkali has been passed. To the MnO2, firstly alkali has been passed. As a result, manganate ion has been formed. And then after to this manganate ion, the acid has been passed. So there was formation of permanganate ion. That was the method of preparation of permanganate ion. And same as the dichromate ion is a strong oxidizing agent, in the same way the permanganate ion is also an important oxidizing agent. Here, how in this one is method of preparation in the laboratory. So in the laboratory, what happened here? Mn2 plus like MnO. There we have taken MnO2. Here MnO or any other manganese 2 oxides. Any two manganese 2 ions that will be reacted with potassium here peroxo disulfate ion, and there will be formation of permanganate ion and the sulfate ion. Here peroxo disulfate ion will dissociate into sulfate ion, and the Mn2 plus will convert it to Mn7 plus. Here oxidation number of manganese plus 2, here plus 7. This one is here. This one is the method of preparation in the laboratory. In the laboratory, the potassium permanganate is manufactured by treating the Mn2 plus salt with the peroxo disulfate and water. So in this case, there will be formation of potassium permanganate and the sulfate ion. Okay. Now that is here. So then after is characteristic. So one of the characteristic is of the potassium permanganate is when you will supply the heat energy, potassium permanganate will convert into manganate ion, potassium manganate. On heating the potassium permanganate, there will be formation of manganate ion and MnO2. That means here oxidation number of manganese is plus 4, here plus 7, here plus 6. Okay. Now about the characteristic here. So I told you KMnO4. Okay, firstly geometry. So also shape will be tetrahedral. 4 oxygen atom is bonded to the manganese. So and they will lie in 3-dimensional space, so that there will be a minimum repulsion between this one. So that is possible when they will arrange tetrahedrally. So shape of potassium permanganate as well as manganate, both. This is of potassium manganate and this is for potassium permanganate. The shape of potassium manganate ion, the shape of manganate ion as well as permanganate ion is tetrahedral. But there will be difference in the color. The manganate ion is of green color while the permanganate ion is of purple color. Okay, that was about the geometry of manganate and permanganate ion. Now let's see its chemical properties. So you already know that potassium permanganate is a strong oxidizing agent. The potassium permanganate ion is a strong oxidizing agent. But here what's the difference arises? That difference arises is that the reaction is taking place in acidic medium or in neutral medium. Acidic medium has been given. I am checking that in a neutral medium or not. No, only acidic medium has been given in your book. Okay, yes, given in neutral medium also. So in case of neutral, there will be formation of potassium permanganate will convert into MnO2, and in acidic medium that will convert into Mn2 plus. Only one thing you will have to keep in the mind, that in acidic medium the potassium permanganate ion dissociate into Mn2 plus, and in case of neutral medium the potassium permanganate will dissociate into +4 oxidation state, that is MnO2. So let's see from 1 to 1. From the beginning, let's see. So it's a strong oxidizing agent. Oxalic acid here. So oxalic acid dissociate into CO2. How is that? You may watch out here oxidation number of carbon. It is C2O4, 2 minus. So what's the oxidation number of carbon? +3. So oxidation number of carbon here is +3, and when there is formation of CO2, oxidation number of carbon is +4. So here oxalate ion has been oxidized to CO2, and the maximum oxidation state of carbon is also 4. Why? Because carbon belongs to group 14 elements. So maximum oxidation number of carbon will be group 14 elements. So group 14 minus 10, that is 4. So highest oxidation number of carbon will be 4. That's why. So basically ferrous converted to ferric, nitrite converted to nitrate, iodide into iodine. You have studied here very well. So very easily you can predict what will be the product. By half cell reaction it has been given here. It's not so much difficult. Like permanganate converted to MnO4, that means you know already that when heated, the MnO4 minus, that means KMnO4 will be heated, then there will be formation of K2MnO4. So when the MnO4, it is has been given oxidation reduction, I get to it later, but earlier we have studied that when permanganate ion will be heated, there will be a formation of manganate. So here what happened here, oxidation number of manganese here +6, and here, +7, and here +6. So that is possible only when this compound have taken 1 electron. So manganese, this compound, so there is gain of electrons, so reduction took place, reduction value happen here. Same here, MnO4 minus, that's acid, and this one taken in case of acidic medium, so MnO2 form. More acid taken than Mn2 plus, that is here. Now in acidic solution, what's there here? So same in acidic medium, you know that MnO4 minus, that is dissociated to Mn2 plus. So iodide converted to iodine, so iodine and MnO4 minus, that will dissociate to Mn2 plus. Remaining hydrogen you balance by this one oxygen. Balancing I shall also teach you in the redox reaction. If you will feel difficulty, then you also watch the chapter of redox reactions, and if you want to solve by the hit and trial method, but you may also use that, but that will be time taking. So who will prepare for the NEET examination and IIT exam for the IIT examination? To all of them, you should watch the video which I shall make for the redox reaction. So, but who are preparing for only 12th board examination, that may use the height and trial method. Obviously here Fe2 plus, so Fe2 plus oxidize into Fe3 plus, and now MnO4 minus, that will dissociate to Mn2 plus. So remaining hydrogen you will balance by the water. Charge actually you will have to balance, like iron Fe3 plus, like that charge firstly you will have to manage. Okay, to balance that, better you go who is not preparing for the IIT main or the advanced, that is only balance them by considering the charge. Same here, you have studied oxalate ion, this was oxidized into CO2, so CO2 form, and KMnO4 dissociate to Mn2 plus, so that's Mn2 plus, remaining water. Same H2S here, -2 oxidation state, so that will oxidize to sulfur here. Okay, H2 minus this one here, that's when KMnO4 will be treated, so that will oxidize into sulfur. Now sulfite, here oxidation number of sulfite will be how much? +4. Here sulfur +4, so that will sulfite will undergo sulfate, so here oxidation number of sulfite will be +6. So oxidation of sulfite, that means sulfite get oxidized to sulfate and KMnO4 minus will reduce to Mn2 plus. Same here nitrite to nitrate, nitrate oxidation number here -3 I think. X equal to here +3, so here +3 and nitrate +5. So oxidation to place, okay, you may find the oxidation number by yourself also. So +3 to +4, and permanganate ion will convert it to MnO2, oh sorry, Mn2 plus, so Mn2 plus here. Neutral medium, only difference will be that here KMnO4 that will reduce into Mn4 plus or MnO2. So iodide will into iodine, okay, but iodine will be here, neutral medium here, that means there is so much water. So I2 will dissolve in water and that will form their oxoacid, that means HiO3. HiO3, hydrogen release, so IO3 minus here. Same, thiosulfate will dissociate into sulfate ion and this one into MnO2. Now Mn2 plus will oxidize into MnO2. So MnO2, one MnO2 from here and MnO2 from here. Okay guys, that was about the compounds of transition metals. Now about the inner transition metals, we will meet in the next video. It's all for this video. Thank you, Team Educate.